Hello, everyone. Welcome to the May episode of the ASP.NET Blazor Community Stand-Up. With us today, we have Daniel Roth.
Hello, everyone. How you doing? I've got to say, that is now the coolest opening graphic sequence. Like the
Right.
.NET logo. Like, what? Amazing. Fantastic.
It's a lot of hype to live up to.
Cool.
Yep.
And we have John Galloway.
I'm excited to have a front row seat. I'm quite excited. Dan was like whipping together demos during the countdown, like throwing it all. He's got a lot.
We can throw that one in. That one works.
Yeah. And myself, Mackinnon Buck. So today we're going to be talking about some Blazor updates for .NET 8. Earlier this year, we did a stream where we kind of showed our plans for .NET 8. So this is an opportunity for us to show what we have so far. But before we jump into that, we will start with some community links. So let's get started with that. So first we have Blazor Apex charts, which is a wrapper around a chart library, a JavaScript chart library called Apex charts, which is a cool way to like add interactive charts to a web page. It has support for like vanilla.js, Angular, React, Vue, but also Blazor. And they have a pretty cool demo site that shows all the different types of supported charts, as well as code examples for how to create them. So it's really easy to get started and copy and paste some code into your own project and mess around with it. The charts are really cool, very interactive. So if you need that kind of functionality for your app, then give this thing a look.
Fancy smancy, yeah. Those look great.
Yeah. And so next we have a blog post by John Hilton, and this is about when Blazor components re-render. So there are like a lot of different ways or a lot of different reasons a component could be re-rendered in Blazor. Maybe its parameters changed, or maybe an event got fired and it had a handler in the component or something. Or you call state has changed, but this blog post goes over all the reasons that a component could re-render. So if that's ever been a topic that's been confusing to you, like when do I have to call state has changed, then maybe this blog post could help clarify some things, and also goes over some things like, how things work under the hood. And so yeah, give that a look if that's a topic you're interested in. Next, we have a set of examples for how to use the MVVM toolkit with Blazor. The MVVM toolkit is part of the .NET community toolkit, which is basically a set of like UI platform agnostic helpers for like .NET apps. And the MVVM toolkit is part of that. MVVM, if you're not familiar, is a kind of like UI design pattern that's familiar in lots of different types of like C# UI frameworks, but it's less common in Blazor, and there isn't yet a official like Blazor MVVM sample. So if you want to use that pattern within Blazor, give this example a look, and there are also some accompanying blog posts that come with that as well. All right, so next we have a podcast or an episode of the .NET Rocks podcast. This is actually from late March, but it's featuring Steve Sanderson and Javier Nelson from the Blazor team, and they're talking about
they brought in the big guns for that one. That's great.
So the topic for that podcast is, well, it's on this page it's called Blazor United, but we've since kind of changed our phrasing, so we're not calling it Blazor United anymore. We're just calling it like the full stack Blazor effort. So as you're listening to this podcast, just in your mind, replace every occurrence of Blazor United with like full stack Blazor, because we're calling it full stack Blazor going forward. But anyways, this podcast is really interesting. They kind of go in depth on some Blazor United topics. And so yeah, if you're interested in that, which I'm sure many of you are, please give that a look.
It's a really good podcast. I actually was at a conference in Romania, and I got I was teaching a 2-day workshop on ASP.NET, and I got a ton of questions on Blazor. I said, okay, we'll take all your Blazor questions on the second day of the workshop. And as I was walking to the workshop, it was like a 20-minute walk. I listened to this whole podcast, and just to make sure that I had all my tech details right. And it was like super helpful. So yeah, a lot of great technical detail here.
Yeah, definitely. All right, cool. And that leads us to the last community link, which is built on Blazor.net. This is a pretty cool site that just has a giant collection of websites that have been built with Blazor. And there's some really cool ones on here that I've never seen before. Like there's this stock scanning app that's like pretty decently complicated. And so yeah, there are a lot of like, full featured apps basically on this page, as well as some simpler ones. But if you're looking for some inspiration or just, some cool examples of apps that are built with Blazor, give this site a look, because it has a lot of really neat stuff in it.
And I think this site is built with Octane, right? This is Sean Walker's project, I believe. This is a CMS style system built on Blazor that is, I think, then hosting this built on Blazor website. So it's Blazor on multiple layers all the way down.
Yeah, I think it may say something in the footer. Yeah, built with Octane.
Yep.
Yeah. This is Octane.
Awesome.
Yeah, we had Sean on to talk about Octane a while ago. It might be good to get an update from him sometime soon.
Yeah, definitely. Cool. But yeah, that wraps it up for the community link. So I think Dan will hand it off to you.
Oh man, thank you, Mackinnon.
Right.
Hello, everyone. I was just looking at all the chat. Like, this is a global stream. Like, we have people from all over the place: Lebanon, South Africa, Italy, Tanzania, I think I saw earlier. Welcome, everyone. I don't know what time zones it is for you all, but if you're like in the middle of the night to watch the community stand up, we appreciate you being here. Thank you for joining. We're going to do an update on all of the new stuff that we're working on in Blazor in .NET 8. We're going to look at some of the features that have made it into the most recent .NET 8 previews, and we'll do some demos. I have a few demos with some stuff that's coming in the next preview that's will be shipping shortly, like any day now, like within the next week or so. So that will be fun. And then I'll talk a little bit about the roadmap for some of the other features, like when ones that are still coming down the pipe for later in .NET 8. Let me move this over here so I can see what I'm talking about. Okay, so can you see me? Yeah, see my screen. Okay, great. So in .NET 8, one of the big themes for Blazor is that we're working to combine the benefits of the server and client into a single consistent programming model based on Blazor. So modern web apps today, they use a variety of approaches to handle their web UI needs. Like maybe your homepage or your blog, that's best handled with server-side rendering so that it loads fast and is easily indexed. In .NET today, we have support for server-side rendering with MVC and Razor pages. But for other parts of your app, maybe you need more elaborate functionality. It needs to be responsive. And that part is probably best to run from the client using client-side rendering. And for that, in .NET, we, of course, have Blazor. But in order to use these two different approaches to web UI together in a .NET app, you currently have to mix different frameworks. So in .NET 8, what we're working on is we want you to be able to use these two things together. And so we're combining the strengths of the server and the client into a single consistent programming model based on Blazor so that you can build full stack web UI using Blazor components. This will all be from within a single project that you can have islands of interactivity based on either Blazor server or Blazor WebAssembly alongside server-side rendered content. And you can easily switch the rendering modes and even mix them on the same page. That's what we're working on for .NET 8. Now, some of you have probably, like Mackinnon mentioned earlier, some of you have probably heard us refer to this effort previously as Blazor United. But that name kind of gave an impression that I think led to some confusion. This isn't a new framework. This isn't even a new hosting model for Blazor. Instead, it's actually just a collection of new Blazor features and enhancements in .NET 8 that make Blazor a true full stack web UI framework. So to avoid confusing people into thinking that we're building something completely new and completely different, we've decided to actually move away from the Blazor United naming and instead just focus on the actual features that we're adding to Blazor. It's really just Blazor in .NET 8. So what are those features? Well, there's 5 main features that we're working on in the .NET 8 timeframe. Server-side rendering with Blazor components, streaming rendering, which I'll talk about what that is in a bit, enhanced navigation and form handling, and adding client-side interactivity on a per component or a per page level, and then also the ability to choose which component render mode that you want at runtime. And these are features that we've shown in prototype form with like the recipe app. Maybe you've seen Steve Sanderson's Blazor United YouTube video. That's where that name originally came from. We started using it, and then it started creating some confusion. So we've now decided to move away from it. But really what Blazor United was just all of these features working together to create that full stack web UI experience. Now, some of these features are already available to try out with the latest .NET 8 previews. Others are still in the works and will be available in upcoming .NET 8 previews. So we're going to look at what's implemented so far in .NET 8. If you want to see all of these features in action, then you probably should go check out either the previous Blazor community stand-up that we did, where we showed a lot of these features, or you can go watch Steve's YouTube video. Okay. Now, most of you are probably already familiar with server-side rendering. We've had it available in .NET and with ASP.NET for a long time in one form or another. Server-side rendering means generating HTML from the server in response to a request. In the case of Blazor, what this means is that we will route requests to a Blazor component, which is acting as an endpoint. That component renders the HTML, and it gets sent down to in the response. Now, in this model, there's no WebAssembly. There's no WebSocket connections involved. You're just getting plain HTML rendered to the browser in response to requests. This is different than Blazor Server. In Blazor Server, you actually have a persistent connection and state being managed on the server so that you get that full interactive experience. In traditional server-side rendering, the connection only lives as long as the request, and the app is typically stateless. So that's what we mean when we're talking about traditional server-side rendering. We're not talking about the Blazor server model in this case. Okay, so what does this look like? Let's do a quick demo of how you can do server-side rendering with Blazor in .NET 8. Let me switch over here to Blazor server-side rendering. We'll get to this other demo in just a second. Okay, so here's a Blazor application, and this app is completely server-side rendered. It popped up over here on my other window. There it is. Looks like a Blazor app. We've got, of course, got that lovely purple gradient that will just live forever, that timeless aesthetic. Maybe at some point we should do a design refresh on the Blazor components, so not every Blazor app looks like the purple gradient. But for now, it's still got it. So now you know it's a Blazor app. If we look at the page source for this page, you can see that it is fully rendered from the server, like we're getting fully rendered HTML in the response. So there's nothing happening client side to set up the DOM. And if we bring up the browser dev tools, and let's like clear out all the caches so that we know there's nothing happening here from a client side interactivity perspective, and let's refresh. Okay. So then all we're getting, there's no .NET.WASM in here. There is this one WebSocket connection. That's actually it's not Blazor Server. That's a piece of the tooling that like enables the browser to refresh as you make changes. That's not a Blazor Server WebSocket. There's nothing set up here for client-side interactivity. This is a stateless server-side rendered Blazor app. I mean, otherwise it looks the same. Like we have the homepage, which is just some static HTML. We have the counter. If we click the counter button, though, nothing happens. There's nothing that's set up here to handle that on-click handler. We don't have interactivity yet, hence this little warning that I added to this page to say, don't expect client-side interactivity with this. Oh, apparently I'm going to need to restart. Let me start later. There we go. I'm not going to restart now. And then the fetch data page, that works just fine because all of the weather forecast data can be retrieved on the server, rendered right into the page, and we see it in the application. Okay, now how is that set up in code? If we go look in Program CS, to set up server-side rendering, we're calling add Razor components to add all the relevant services. And then we are mapping all of our routable Blazor components to endpoints, to actual endpoints that will be in the endpoint routing sense. Okay, here we're passing the main layout component to map Razor components. That's so that the API knows where to look for the routable components. It will basically, in this case, only look in the assembly where that main layout component lives. Now, otherwise, the code for this app looks almost entirely the same as a normal Blazor app. Let's take a look. So we got our index page. This is the normal index page that you'd see in a Blazor app. I added one thing, which was I added this component parameter so that I could pass in a message and use that for the heading. But otherwise, normal index.razor file. The counter component is exactly the same, except for the little warning that I put on the top. There you can see that on-click handler. In this app, it's just doing server-side rendering, so there's nothing set up to handle that on-click handler yet. In the future, we will allow you to add islands of interactivity like this. And then the fetch data component is literally character from the same. There's nothing changed in fetch data. Now, where's the root of this app? Like normally in a Blazor app, you have like an underscore host.cshtml file that's kind of like the root page. Or in a Blazor WebAssembly app, you have like a index.html, which is just a static HTML file that hosts the rest of the application. Well, in this case, the layout is the root of the application. Like we have our root HTML tag in the layout component, and then this is setting up the frame content for each of the pages in the app. But notice there's no script. We haven't set up any client-side anything yet in this application. We're just rendering the body of each page into the layout, and we're done. Now, you may have also noticed that there's no app.razor file here. There's nothing that's actually setting up the Blazor router. There's no client-side routing happening. All the routing is happening using endpoint routing. So we're not using the Blazor client-side router in this case. That does also mean that there's no concept in this app yet of a default layout. So to apply the layout to all the components, I'm just using this imports.razor file and then using the @layout directive to apply the main layout to all the pages. So that is how that's all working. Okay. Now this model of having a map Blazor components call where we just find all your routable components and set up endpoints for them. We think that's going to be the most common pattern for people who are using server-side rendering with Blazor. But there are some other approaches that are available as well. For example, you can just route to a Blazor component using endpoint routing, and that's what's happening down here. So here in this call, we're mapping /route this route to a Blazor component. We're using this Razor component result, which is a way that
you bump the font size up just a bit, Dan?
Oh, sorry. Yeah.
No worries.
Is that better?
That's great. Yeah. Thank you.
We have this Razor component result that you can use to render a Blazor component from an endpoint route, or in a second, we'll see also you could do it from a controller. And the component I've picked here is just the home page, the index component. And this is where I'm passing in a component parameter. That's why I set up that little message parameter. So I'm specifying what message should appear in the main heading. So if we go back to the app, and if I browse to /route, then we hit that route, and our parameters being passed in. So we see hello from route now instead of hello world. We're still getting the layout. That's because of that underscore import.razor file that was applying the layout to all of the components in the application. So the home page has the layout kind of baked into it. Okay, so that's how you can just route any Blazor component you'd like. We can do this from MVC controllers as well. So up above, I do have an MVC controller aptly named MVC controller, and it has an index action, and it's also returning a Razor component result. Again, that same index component, the home page, but I'm passing in a different message this time, hello from MVC. So now if we browse to /MVC/index, then we should be able to hit our MVC controller, and that again returns a Blazor component. In this case, it's has the parameter hello from MVC. Okay, so that's the way that you can now render content from the server using Blazor components. Very similar to what you could do with Razor pages or MVC views, but now you can do it with Blazor components and have the strengths of the Blazor component model available to you server side. Now we are also working on enabling support for form handling so that you can do form posts to a Blazor component and then just handle that using a normal like Blazor edit form, where the logic for handling the form post lives in your like on valid submit event handler, and we'll have model binding and validation there as well. That's coming in stages. Like the first parts of the Blazor form handling support with server-side rendering will happen in Preview 4. You'll be able to at least set up the endpoint for handling the form posts and some very low-level APIs for getting at the form data. In Preview 5, we'll be adding the actual model binding support so that you can bind to strongly typed objects and have all the validation systems kick in. So that will be coming in the next couple preview releases. Is there any questions so far on that, John? I haven't been watching the chat very carefully.
Let me see. There was one about... Why do you need to pass the layout to map Razor component map Razor components as well as using layout directive?
Great question. So let me go back to the code for that. So in the case of the program CS logic, so here we're by calling map Razor components, the goal of that call is to find all the Blazor components that you want to set up as endpoints, like in the endpoint routing sense. And it's going to go looking through the types to find components that have the at page directive that basically have a route attribute applied to the generated C# type. This API needs to know, well, what assemblies do you want me to look in for those routable components? And so the pattern that we have right now is you pass in a type, and we'll look in the assembly for that type. In this case, the main layout isn't. I'm not actually specifying the layout for the app by doing that. I just picked one of the components in the main app assembly that I wanted it to look at for finding the rest of the routable components. To actually apply layout to the pages, that's what that at layout directive is doing up here. That's basically the Razor compiler for each of the page components is getting some code into it to saying that your layout is the main layout component, and that's how that's working. Now, in the future, we are actually planning to integrate the Blazor router into endpoint routing so that you can have a notion of just a default layout like you would in a normal Blazor app today. That's usually set up using the router. So the app.razor component that's setting up the Blazor router will most likely come back in a future .NET 8 preview release. But for preview 3, the way you have to do it is like this. Like you have to manually apply the layouts, and there is no Blazor router being used in the request flow at all yet.
Okay. Let me see. Okay. How do you render a component within another component in Razor syntax?
Yeah, that's super easy. So like if I go to the home page and if I wanted to like add, say, a counter right here, you just use the tag syntax. So it's the name of the component looking like an HTML tag. So if I run this now.
And what you're showing there too is the page itself is a component, right? So you're showing a component and a component right there.
Yeah. So this index.razor, that's a component. You define components in Razor files. And then I'm using the counter component, which also happens to be a page, but that doesn't prevent you from using it as a component if you want to. And I'm just adding it to the home page. And that's why now you see a counter showing up on home in addition to the other home content. So it's just tags. Like this page title tag up above, that's also a component. That's a component we provide in the framework for setting the page title metadata on the HTML page. It's another example of a component usage.
Okay. Question from Sean: For those of us that have invested in tag helpers and view components, will we have to abandon those to adopt server-side rendering Blazor?
So MVC, Razor pages, these are frameworks that are heavily used and loved by hundreds of thousands of developers. So the code that you're writing in CSHTML files using view components and tag helpers and partials, none of that is going away. That will continue to exist. Blazor, what we're doing with Blazor is sort of leveling the app model so that you can have a full stack pattern for handling both your server-side concerns and your client-side concerns. It's a component-based programming model. And that's a little different than what MVC and Razor pages offer, which is much more request reply centric. Like the request is like right there in your hands, and you can mess with headers and all that type of stuff. You're really right there at the HTTP layer if you want to be there. In Blazor, it's a component framework, and we want components to be able to like you have the option of rendering a component on the server or the client. So there'll be some more abstraction insulating you a bit from the HTTP layer so that you have that flexibility. If you prefer to have a programming model that's very request reply centric, right there at the HTTP layer, then MVC is a perfectly valid choice, or Razor pages. So MVC will continue to be there. Lots of people will continue to use it. As you saw with the controller example, you can start adding Blazor components to an existing MVC app if that's what you want to do. We also have the component tag helper, where you can take a CSHTML file like an MVC view or a Razor page and embed a Blazor component inside of that. That's also supported. We use that for pre-rendering in Blazor server apps. These technologies are intended to be used together. But we think there's a big productivity gain to be had by bringing Blazor's component model to not only be used on the client, but also to be available on the server.
Okay.
Long story short, none of your existing code is going away. It will continue to be there. You don't have to migrate to anything. You'll be fine. Like, so if you're building an MVC app, you should probably continue to build an MVC app. There's no need to like move your app to now be completely Blazor if that's not useful to you.
Okay.
Maybe one more, and then I got a bunch more stuff I want to show.
Exactly. Yeah. Okay.
Or maybe should we just go on? Actually, if you don't, let's
that's
go on,
fine.
and then we come back to more questions. All right. Let's go on the next stage, level 2. All right, where are we? Here we go. Okay, so that was just plain traditional server-side rendering. Now let's look at enhancing the server-side rendering experience with some client-side support. And the first feature we're going to look at is streaming rendering. So what does streaming rendering do? Well, what streaming rendering allows you to do is if you have pages that have long-running async tasks, like if you're querying the database or you're making an API call, like from the server, and you don't want to have to wait for those tasks to complete to get pixels down to the client. That's what streaming rendering enables you to do. You can render the page fully with some placeholder content for any of the places where you're waiting on those long-running async tasks. And then when the tasks complete, the updated content, it looks like this. I'll do a little animation. So you get the original content for the page while you're doing a long-running task, like querying the database. And then when the database query has completed, the page can render again. It goes down on the same response stream for the original request. And then a little bit of Blazor client-side logic helpers can then apply the changes to the live DOM. So you get pixels on the screen really fast, and your app feels more responsive. Let me show you what I mean. So if I go back to our Blazor server-side rendered app, we have our fetch data page, right, where we can render some weather forecasts. And let's imagine that getting the weather forecast data requires making an API call that takes a little bit of time. The weather forecast data is currently coming from this weather forecast service. It's just a simple, generating a bunch of random in-memory weather forecasts. But let's imagine it's actually coming from a proper service. And to simulate that, I'm going to add a little bit of code here to add a task.delay for a second, as if I'm making an API call to some remote service. Okay. Now, if we go and rerun this with just that change, what do we expect to have happen? Well, by default, you need all the async work to complete on the page in order for the page to render. So if we go to fetch data, let me click away and I'll click back to it. And click 1000, boom, then it shows up. So it's having to wait that second while that imaginary API call is being completed before it can fully render the page. We can do better than that with streaming rendering. So to enable streaming rendering, first of all, we are going to now add the Blazor script to our layout and a little bit of client-side functionality that the framework will provide for you. So I'm going to add this. So blazor.web.js, new thing. And then let's turn on streaming rendering on our fetch data page. So I'm going to fetch data. And up at the top, I'm just going to add an attribute to say, I would like this page to have streaming rendering support. You don't always want streaming rendering. Like, it can cause content to shift around. It's something you really need to design for in your app, so you opt into it. So what I expect to happen now is that when I go to this page, I should get it immediately. But since I don't have the weather forecasts yet, I should see that loading ... And then a second later, when our API call has completed, then there should be an update that gets sent down to the client and applied with the actual weather forecast data. Okay, so let's rerun this again. And okay, so now if I click on fetch data, click, you can see there's the loading ... And then a second later, the weather forecast show up. So I'll do it again. So click, loading, and then the data. And that's all in one request. There's no Blazor server circuits happening there. There's no WebAssembly involved. This is still fundamentally a stateless application doing server-side rendering. It's just you get that better, more responsive user experience. So that's streaming rendering. That's not available in Preview 3. This was using the Preview 4 bits, which will be available very soon, like within roughly the next week or so. All right. Well, now that's basically what we've got implemented in the .NET 8 bits so far. Things that we still plan to enable in .NET 8 that we've shown in prototype form is enhanced navigation and form handling. In this mode, what Blazor does is it will intercept whenever you navigate to a new page or when you submit a form post. And instead of like letting that reload the whole page, it will do the request using a fetch request. Let's say you click on something, Blazor will intercept that navigation, do a fetch, and then take the HTML that comes down in the fetch request response and intelligently patch that into the live DOM. This means that you don't get like the screen blip when the whole page reloads. It feels fast and smooth whenever you navigate, or if you do a forum post. Like if you do a forum post and you get the response, you don't lose like the scroll position on the page or any of those things. This is not available yet in .NET 8 Preview 3 or in 4. I think the plan is that this will actually land a little bit later in the release, around like Preview 6. Right now, we're working on adding the client-side interactivity pieces, which is what I want to talk about next. So we had in previous demos, we've shown that you can like take a component or a page and say, I would like this to now use Blazor Server or Blazor WebAssembly, so you get that full interactivity. Like imagine that counter component that we have. You want to actually allow the on-click handler to be invoked by some piece of .NET code, either running server side or on the client. That is what we're working on right now for probably the .NET 8 Preview 5 release. So not this month. Most likely next month, you'll be able to sprinkle in a little client-side interactivity onto a page. And this work will also then eventually include the ability to decide at runtime whether you want to use the Blazor WebAssembly model or the Blazor Server model for a given component. Okay, so those are things that are still to come. Those are all the features that make up the full stack web UI effort in .NET 8. But there's more. Like we're not just doing the full stack web UI. We have a bunch of framework improvements that we're also doing, which I'll talk about next. Before I go on to those, was there any questions about enhanced navigation or streaming rendering, interactivity?
Yeah, there's a ton of questions. The important thing is to sort through which are the ones to ask in this section. So I think this one's good here. How does streaming rendering work on the wire?
I don't know how well I can show this. We can try. Let's see. So if I and then let's clear that, and then if I it looks right. So I browse, and if we look at the waterfall, maybe so it's all a single request. I don't know how much we can see, and it's a second long. So how do I like that? No. I don't know how to get the more. Where's my side scroller on the browser depth tools? You can see some total. I don't know. Yeah, but what you should see on the wire is it's one request. The initial request from the browser hits the server, and you get a full payload of HTML with the loading ... in the source. I think we should see that in the source, right? Let's see. Do we see that? No, we got the. How does that? That's interesting. Why it treats that as the source? I'm not actually sure why that showed that way. Like that, the initial source that you get has the loading placeholder, and then later, like Blazor basically receives an additional streamed payload from the server that it then applies to the live DOM with the actual weather forecast update. So it's like doing clever DOM manipulation at that point, which was one of the nice things about basing this programming model on Blazor, is that Blazor knows about how to like look at the DOM and figure out what's changed and update things. So yeah, on the wire, it looks like a request response. It's just that there's like an additional payload that comes later after the first response.
Okay. All right. I mean, there's some more kind of general questions, but that's probably the main.
All right, we'll save those to the end. Maybe we'll do those later. All right, let's talk about like static site generation. So one of the nice side effects of adding server-side rendering support to Blazor in .NET 8 is that you can now also render a Blazor component completely outside the context of ASP.NET Core. Like you can take a Blazor component and render it to an HTML string or a stream from like a console app. So this is really useful. We know like a lot of people like using Razor as a templating language for things other than like HTTP responses. Like maybe you're generating HTML fragments for a variety of reasons. One common reason is that you're trying to auto-generate emails from the server, like in response to user interactions. You can now use Blazor components in .NET 8 in order to do that, and it's pretty straightforward. Let me show you. So this app is not a web application. This is just a console app. So we just have program CS. And what we're doing is, first of all, we're just setting up a service collection container because we're using DI and setting up logging. And then we're going to use this HTML renderer API, new API in .NET 8 to render a Blazor component. I have a very simple Blazor component right here that's just going to like print out the current time, but this component could be arbitrarily complex. Like you could use a whole component hierarchy in here if you wanted to. And then we just call render component async and pass in the component that we want to render. You can pass in component parameters. Here I'm just passing in an empty parameter set. And then you can render it to an HTML string. You can render it to a text writer, wherever you like. Now, the one little tricky bit is you do need to render the components in the context of a Blazor component dispatcher. That's what this dispatcher property is doing. So you call dispatcher.invoke async, and then in here is where you do your actual component rendering. But if we run this, we should see that we just get the rendered HTML from a Blazor component just as a string or as a text file if you wanted to do that. We hope to use this in the future as the basis for like static content generation support in Blazor applications as well. That's not planned for .NET 8, but it's on our longer term roadmap of what we're planning to do. We hope that this will enable a bunch of cool scenarios for people building tools and templating type of functionality in libraries. You can now use Blazor components as a basis for doing that.
This is so cool. I've followed, like, there have been a lot of open source efforts to try and kind of shoehorn this in. People doing like reporting, email notifications, all sorts of things, right? And templated HTML has always been like, and then T4 templates or all sorts of different templating systems. So people are going to love that.
Yeah, I mean, we've always had this this tension on the aspnet team that we built Razor, and Razor was designed actually from the beginning to be a general purpose templating engine for not even necessarily just for HTML, for anything, but we used it heavily, of course, for generating HTML from the server in web applications, and a bunch of things got kind of tied up in that, and it was always hard to pull resources away to handle non-web scenarios, given that was where our main focus and scope is. We're really excited also that we've been able to light up this scenario for people that are interested in using Razor in this way. All right, so that's generating static HTML content using Blazor components. There's a bunch of additional Blazor enhancements that we've been working on as well. So in .NET 8, we are planning to ship a stable release of QuickGrid. QuickGrid is our fast and functional data grid component for Blazor. It's great for simple scenarios where you want to show a bunch of data on the page. We have added support for sections. If you're familiar with MVC and Razor pages, they've had section support for a while, where you can create outlets for content that then get filled in by pages in the application. In Blazor, we're adding that support as well, but based on components using the new section outlet and section content component. You can now route to named elements on a page, like using fragment style routing. So that's coming. And then we've also enabled support for monitoring circuit activity so that you can detect idle circuits. I'm just going to show you what all these things look like in code. So first of all, for QuickGrid, it's easiest actually just to go to the QuickGrid demo site. So aka.ms/blazor/QuickGrid. And this is actually, I think this is all Blazor WebAssembly. This is a Blazor WebAssembly app that's hosted on GitHub pages that demonstrates the QuickGrid component, and it supports pagination, and it supports sorting, and you can put little widgets on things so that you can filter. Like if we want to look at the Olympic performance of Canada, we can do that. We can do virtualization. So this is another QuickGrid that's rendering like 22,000 results from health, I think it's like medications data set. And as you can see, as I scroll, the data is getting filled in as I scroll, so that you're not having to load in all 22,000 results all at once. You can virtualize the data set. You can do styling on it. Just uses normal CSS styling. Like if you want to have this wonderful enterprise grade styling design for your grids, you can do that too. Now, QuickGrid doesn't support like every single data grid feature. It's designed to be a good and simple solution for basic use cases. If you need a fully featured data grid, we would still encourage you to go check out the various data grids from the control vendors that are out there. They have wonderful Blazor data grids that you can use. But for a lot of simple scenarios, we think Quick Grid is useful. We previewed it with .NET 7. In .NET 8, we've decided to just go ahead and ship a stable and supported release. So that's Quick Grid.
It's I've played with it a bit. There's a lot you can do there, like with templating, like including images. Like there, you're showing a simple flag, but I mean, there's a lot that you can actually do with that, and the virtualization support is really awesome.
Yeah, it's very, very functional. I mean, it's kind of similar in flavor to like for our old school web forms fans.
Sure.
We used to have a data grid control in web forms, so it's in that same spirit. Something basic that's just there that you can use. But there are lots of other great data grids in the community and also from the control vendors that are also worth a look.
Well, you're showing that. Another question: Are there new features being added to Quick Grid in this?
We don't currently plan to expand the functionality, and actually, I think there was even we decided to pull column resizing actually from Quick Grid in .NET 8. Doing column resizing correctly in a very framework general way was proved difficult when we were doing the API review. So that was actually a feature that got removed for .NET 8. So take a look, see what the feature set has. That demo site pretty much demonstrates every single feature that the Quick Grid has enabled. If you think there's something that's just super basic that should be there, let us know. But we are trying to keep it scoped. Like we're not trying to be the Dev Express, Infragistics, Telerik data grid of the world. Like they know what they're doing, and we want to let them continue to do so. But for basic scenarios, Quick Grid is quite sufficient.
One other thing there you mentioned kind of in passing, but that demo site is hosted on a GitHub Pages, so it's a static site, right?
That's right. Yep, and actually it's using a really cool open source project. Jay Sakamoto, I forget how to pronounce his first name, but he does a lot of really cool Blazor open source projects, and he has a static site generator library that he has built for the existing Blazor framework, even without the work that we've done in .NET 8, that we use on that site to improve the performance of the site even better. So thank you, Jay Sakamoto, for your contributions.
I'll get a link for that.
Let's talk about section support. So sections, super easy feature to use. You can define outlets for content using the section outlet component, and you can give them a name. So here I'm defining this outlet in the main layout.razor file, and I'm putting it in the top row, like that top bar that's on the default Blazor template. And then when I want to fill in this outlet with content, you just use the section content component. So here's section content on the home page, and I'm just putting in some static content here. Again, you reference the same name to say where you want this to go. The counter component, I'm defining section content, and I'm putting in another button that clicks this, has the same increment count functionality as the main counter button. So an extra button. And then on fetch data, I'm rendering the weather for tomorrow, like the most recent weather report. So if we run this, oh yeah, and I have show some. We'll get to that one in a second. So if we look at the home page, we've got home showing up in the top row. On the counter page, we see we've got the counter button that's showing up here, and it works just fine. And then on the fetch data page, we're rendering the weather from tomorrow. So that's sections. It's just an easy way to have pages be able to contribute content most frequently to your layout. This little link here is also a new feature. This is the ability to link to named elements on a page. So let me go back to the code. So on the fetch data component, I've defined an H2 at the bottom of the table that has an ID, ID of place. And then on the home page, I've got just a normal anchor tag that links to fetch data hashtag place, so that we can link to a particular ID on the page. This was something that didn't work in previous Blazor releases, but is now also fully supported.
There's a few questions on section specifically.
Oh yeah, go ahead.
So what is the purpose of section content versus render fragment?
Let me get my StreamYard back over here. So, okay, render fragment. Render fragment is like, I want to capture a chunk of rendering logic, like Blazor rendering logic, and hand it around. So for example, if you have child content on a component, that usually gets like the inside of the tag, that will get captured as a render fragment, and then the component itself gets that child content as a render fragment that it can then decide where to render. You can just say like, I want to render this over here. Sections are a little different. Sections are like defining a placeholder that gets filled in later, like someone else contributes to that component. So you don't pass like a render fragment to the layout. And that in this world with sections, you just say there's a gap, there's a hole here that anyone can fill. I don't care who it is, like whoever. If someone defines content for the section, it'll get picked up and put there. And it's a sort of a general purpose piece of infrastructure that we actually we used it in .NET 7. Like in .NET 7, we added support for modifying the head on the page.
Mm-hmm.
Like you want to change the title or add additional meta tags to the head section of your HTML page. There was this head outlet component that you could put there. And then components could later say the title is this, or add this, meta tag here. So it was a way to define a hole that could be filled in later when there's not really a way that you can like say, here's a render fragment, please put it in the right spot.
Got it. So it's very, and this was brought up, this is pretty similar to section support like in MVC and Razor pages as well, right?
It's very similar. Yes. Okay. It's similar in concept, but it's component based instead of being based on the CSHTML syntax.
Okay. There's a question here. Can it be required or optional the same way that MVC does?
That's a great question. I can't remember the semantic. Mackinnon, do you remember, are sections required by default? I mean, I could remove one.
Yeah. So section outlets don't require a section content to render content to it. So it is optional. Yep.
Okay. Let me see. One more question here. How does it work with cascading values?
Yeah. So currently, what will happen is cascading parameters will be inherited from where the section outlet is rendered. But that's behavior that we're thinking we might change by the end of .NET 8 so that it inherits the cascading parameters from the section content, which would make more intuitive sense. And there are some other like things that we're looking into regarding sections, like how do they interact with error boundaries and how they work with stream rendering that we'll have to kind of polish up before .NET 8. But yeah.
Okay.
Hopefully that answers
there
your question.
A few questions wondering about like, this one here. If you have multiple, like, do you end up with collisions if two are trying to, or does it just kind of compile them together, or what happens there?
I think what happens is the one that's rendered, the section content that's rendered last will take priority. There's kind of like an internal, well, I actually don't know if this is totally true, but I think there's like an internal stack that keeps track of like the order in which like the contents were rendered, and then like as they get disposed, then the one that's like that was added latest always shows up. I'm pretty sure that is how it works, but
okay, cool.
But yeah,
I'll let Dan get back to it here.
I was just trying that out to submit to double check.
Oh, okay. Yeah.
Does anyone can experiment with these things? They're meant to be experimented with. So yeah, the last one in this particular case.
Cool.
Yeah. All right. Oh, so now I'm going to try and this is actually Mackinnon's feature. This is one that Mackinnon built. So I'm trying to do it justice, Mackinnon. You might have to set me straight. Okay, so the last thing I was going to show here is monitoring circuit activity. So in .NET 8, we've added a new API to the circuit handler API so that you can get notified of inbound activity on the circuit. Now, if you're not familiar with circuit handlers, circuit handler is an API that has a bunch of like lifecycle events for the life of a circuit, like when the circuit gets created and when it gets torn down. So that's this right here. You register them in DI, and there's this new API now that you can use on Circuit Handler called Create Inbound Activity Handler, and it's a very funky API. Get funky? Anyway, okay, no laughs. No. So what you do is it gets handed a next pointer that you get, and then that you can choose to call, and then you're supposed to return a func, and that's your actual handler that will get called as inbound activity occurs. So it's very much like the middleware pipeline. If you're familiar with middleware in ASP.NET Core, very similar style of setup. And so what this allows you to do is, because you get notified when any inbound activity occurs, you can look for idle circuits, like circuits that aren't being used at all. And the idea here is that this is one of the first pieces to enable you to manage your circuits. Like if you want to evict circuits that aren't being used, like a user just sitting there not using the app, and you want to save on server resources, because circuits are your server resources, connections and state. You might decide to evict a circuit that appears to not be to be used. We haven't actually added the eviction APIs yet, but we plan to do that in a future .NET 8 preview release. So the way this is implemented in this sample is I have a timer that we just reset and restart every single time some inbound activity occurs. And if that timer ever elapses, then it's raising an event on the circuit handler instance. And then this gets registered in DI. So I've added the idle circuit handler. And here I'm specifying an idle timeout of just 5 seconds for just demo purposes. And then on the home page of this app, I am injecting the idle circuit handler so that I can hook into that event, and just so I can display a little bit of UI whenever this circuit goes idle. So I'm the page goes to sleep if you're not using it. Okay, let's go ahead and run this. And okay, so here's the app. And if we just let it sit, then see this 5 seconds has elapsed, so the circuit went to sleep. If I start clicking on things, so I'm sending inbound activity, and then I stopped, wait 5 seconds, then we get our LZ handlers. I mean, this works with multiple pages, multiple users. So if we had like multiple of these going, as I click on things, oh, that one just went to sleep on me. See if I can keep them both awake, and then if I stop clicking on the first one, then it should go, yeah, that went to sleep. And I stop clicking on the second one, 5 seconds, the other one will go to sleep as well. So this is a way you can detect idle circuits, and then in the future also be able to manage, help you manage resources on the server. Yeah, no dark mode sleep. Yeah. Sorry. Cool.
So you did explain it, but can you kind of go at a basic level? What is a circuit? Like there are a few people that didn't.
Yeah. So, people often use the word session, but it's kind of an overloaded word. So we made up a new word when we built Blazor Server to represent the user's engagement with the app. So a user comes to a Blazor Server application that sets up that usually a WebSocket connection with the server, and now there's some state that's being managed on the server for all of your components. The components are running server side. Any of the component state is being handled server side as you use the application. Now that circuit life can actually live beyond the connection. Like if you lose network connectivity, we'll actually hold on to the circuit state, the server side state for that circuit for a little while, so that the user, if they later reconnect, they can connect back to that circuit and keep on going. Like you went into a tunnel while you're on the subway or whatever, and you lost network for just a little bit, you can still come back. So the circuit is that notion of the user's a single user's experience with the app, the connection and the server side state that's driving their user experience. The circuit handler then is an API that allows you to look at the circuits that are currently set up in your app, all the users that are using your application, and see when do they get created, when they're getting torn down, and so forth. And now you have an API also to tell when are they actually using that circuit, are they actually sending any inbound activity.
Okay,
cool. All right, so that's we saw quick grid sections, routing to named elements, detecting idle circuits. There's a bunch of WebAssembly investments that are happening in .NET 8 as well. Some of these have shipped, some of these are still in the works. We are planning to ship multi-threading support. That is very much in the works and is getting near to being previewed in for Blazor applications within the next month or so. We had multi-threading support in preview in .NET 7, but it was only available when you weren't using Blazor. Like if you were using the new what was it, WebAssembly browser app or WebAssembly console apps, like there were these lower level abstractions where you could use .NET on WebAssembly. In that mode, you could try out multi-threading, but we've been working very hard to up level that so it's available in Blazor applications. That is coming in .NET 8. It's not available in preview yet, but it should be available within the next couple months. It's a lot of work to harden the runtime to support these multi-threaded patterns, but we are really, really close now. Hot reload improvements. The hot reload capabilities of the .NET WebAssembly runtime has lagged behind what the Corsular can do. In .NET 8, we are pretty much at parity already, and we expect to be at parity in the .NET 8 timeframe. So any type of edit that you could do with like a Blazor server app, you should be able to do with a Blazor WebAssembly app in .NET 8. Many of those edits are now available, and we are expanding the set of available edits as well to different additional types of edits that will now be supported with Hot Reload.
There's a question on Hot Reload, like for instance, third-party components. Would those updates also be helping for those as well?
So with like I was saying, Blazor WebAssembly, particularly in .NET 7, supported a very limited set of edits. Like it could basically do method body replacement, and that was kind of it. In .NET 8, it will have the same level of support that you get with server-based applications or core CLR-based applications. So you can like, rename parameters and do a whole bunch more things. I think we're also working on expanding the set of edits so that more common scenarios will work. Like generics is one that's very common that we know people hit. If you have a generic type and you're using Hot Reload, that's not something that's supported in .NET 7. That's something that we've been working on for .NET 8. I think the big one that people hit a lot though is like lambdas that capture state, like capture like enclosing parameters. That's really common when you have render fragments that are flying around in Blazor components. That one is still going to be an issue, I think, in .NET 8. I don't think we're going to get to that one, but it is on our roadmap to address. So we basically, for all those people that send us telemetry so that we can look at the product, know what's going on, thank you for doing that. We look at the most common hot reloaded changes that resulted in that couldn't be applied. Something we often call those rude edits, which I know is a weird name, but a rude edit is when you get that dialog that pops up and says, hey, you just made a change that I can't hot reload into the app, so you have to restart. We keep track of the signal of what are the top types of edits that result in that dialogue, and we're just basically working down the stack. So things will continue to get better in .NET 8. I think though, like the Lambda one, that's an unfortunate one that we still need to address, but it is on our roadmap to address at least in the future.
Okay.
Cool. Other things, JIT-terpreter is a feature that I'm super excited about in .NET 8. So this is partial JIT support on WebAssembly, which is amazing. Like I never thought we would actually get that. I would always ask about, can we get a JIT for WebAssembly? And we're like, WebAssembly doesn't really allow for that because loading WebAssembly modules, like what does a JIT do? You generate native code on the fly for the runtime, and then you load that instead of having to look at the IL instructions that are in the .NET assemblies, and that makes things much faster. There was an issue that loading WebAssembly modules required doing an async load, and that was just at odds with the way our runtime worked. But there is a facility to do synchronous loads if the chunks are small, and we have now incorporated that into the .NET WebAssembly runtime so that you get this really actually dramatic performance boost. Like for some low-level operations, it's like 5x faster, JSON parsing significantly faster. And that the numbers that I have on the screen were from when we first shipped the JIT-terpreter in .NET 8, and these are old. Like it has gotten much faster since then. So if you publish your Blazor WebAssembly app and you're not using AOT will still be the fastest, because that's basically taking everything and turning it, almost everything, and turning it into WebAssembly at the expense of a much larger download size. But a JIT-terpreter will be a nice sort of middle ground. It's enabled by default. You don't have to do anything to turn it on. That will give you much better runtime performance for Blazor WebAssembly apps. Speaking of better performance, we have turned on SIMD and exception handling support by default when you're doing AOT in .NET 8. So that should give you a big boost if you're using WebAssembly AOT. We are working to make Blazor CSP compatible in .NET 8. That hasn't completed yet, but that is in the works. And then we are working on a new...
I'll admit, CSP, I'm forgetting. What is that?
Oh, sorry, content security policy.
Oh, okay.
Yeah, so if you want to lock down your app using content security policy, Blazor currently has some patterns in its scripts that prevent that. We will enable that in .NET 8. And then we're adding a new packaging format for Blazor WebAssembly apps that makes them more web-friendly. Today, we download normal .NET assemblies to the browser and we run them, which is super cool. But those DLL files are Windows executable files. They will run within the browser security context, security sandbox. So they can't do anything that you couldn't do with JavaScript. Like the WebAssembly runtime will run those DLLs within the browser sandbox. So it's basically just a data format at that point. But we have received reports that some security software takes issue with the download of DLLs over the web. They're like, "What are you doing? Like, what is that? That's Windows XE? No, sorry, you can't download that in this environment." So restricted environments, we have received some reports that some Blazor WebAssembly apps are getting blocked. So to address that, we're providing a new packaging format for the DLLs that basically strips off all of the Windows nativeness parts of what a .NET assembly is. I mean, .NET assemblies, they started on Windows, so it's kind of a legacy concept that they have all these PE file headers and things on them that aren't technically needed to run them like in a browser environment, but they're still there. We'll be repackaging them so that hopefully that will no longer be an issue. And we've taught the runtime how to then also handle that file format.
Wow.
And then lastly, we're also working on WASI support, or WebAssembly System Interface. This isn't really related to Blazor directly. Like Blazor doesn't use WASI. Blazor runs in a browser. WASI is really actually about being able to take WebAssembly-based code and run it outside a browser. Like if you want to run it on the server, you can. In .NET 8, we are working to support the WASI standard so that you can use .NET to run in WebAssembly-based environments that are outside a browser environment, like in a server environment.
Now, does this relate? I know it was an experiment, but we had .NET Isolator was something Steve Sanderson. I looked at your face and said your name. Steve Sanderson was on showing .NET Isolator, and that was using some isolation WASI craziness. Is this related, or is that a totally separate thing?
It's related. So what you will do with WASI is it's very much an emerging technology. Like people are exploring using it for isolation purposes, exploring using it as an extensibility model, exploring using it for like serverless patterns. It's an area that's ripe for innovation. And Steve, of course, being the innovator that he is, has been playing around with a lot of stuff. He's done a lot of mind-blowing demos with the WebAssembly tool chains. Like I think he has one where, like a year ago, he took all of aspnet core and through WASI, like got it running in a browser in like a service worker, so you could like host an MVC app from within the browser itself.
From the browser tab, basically.
Not something you would ever do, but just showing what's possible. And the .NET Isolator was an experiment he did like with using the WebAssembly isolation boundary as a way to isolate .NET code. Like a lot of services have models where users can contribute code to the service in one way or another. Like think user-defined functions in a CDN, or anything that allows you to like upload some simple logic that the service is then going to run for you. They typically need a way to isolate that code safely so that you can't upload malicious stuff, or you can't accidentally like harm the service or other people that are running code as well. WebAssembly is attempting technology to do that because it is based off of the browser security model. So you get some isolation guarantees by running on WebAssembly. So he's been playing around with that. The things that you see on like Steve do, those are very future looking. So don't expect like .NET Isolator to be shipped in .NET 8. That's not part of the plan. But we do have the basic core support for WASI is coming in .NET 8. There is in the next preview, preview 4, there's a very basic template where you can try running some .NET code on WebAssembly using the WASI system interface. I can show you that really quick. Let's bring up a terminal. Okay, so to try out the WASI support, and this is I think you'll need preview 4 bits to do this. If you try it with preview 3, I think the workload that you need wasn't made available yet. But if you look at the workloads that I have installed, I have this WASI experimental workload. And by the way, the WASI support for .NET 8, the plan is that it will still be in preview. We don't think it'll be done in .NET 8, but it's something you can still play around with. So you'll want to install this WASI experimental workload. So .NET workload install WASI experimental. That's how you do that. I've already done that, so I don't need to do that. And what that will do is that will then install .NET new list, a new template, which is this this WASI console app template, or WASI console. And this is just a console app that will run on a WebAssembly runtime run your .NET code on a WebAssembly runtime as a console application. In this case, it uses, I think it's using WASM time. So I previously installed WASM time on this machine to enable that to work. But we can then create one of these. I don't think I have one yet. Okay, so .NET new WASI console. Call it WASI app. And let's look and see what that's got in it. Here's our app, and it's just, program CS, console write line, and it's got some, fancy stuff in the project file to set up that we want to run in a WASI-based environment. So a runtime identifier. By default, this template is set up so that it will use basically the .NET WebAssembly runtime to then run your app. So it's not by default going to create just a single WebAssembly bundle. That is supported, going to be supported as well, but it's not working yet in Preview 4. I was trying to get it working before this community stand-up, but that is also coming. But for now, what we can do is if I just .NET run our WebAssembly-based console app based on WASI, okay, what we can see in here is that it built the app output, and here it's calling into WASM time and pointing to the .NET WebAssembly bundle and then running our built application, and then we get hello WASI console. That's being based off of the WASI interfaces. So very early initial support for WASI. That will be coming and available for you to try out soon. All right. I think that's it. So here's a summary of all the things that we're working on for .NET 8. First column is all of the full stack web UI efforts with Blazor. Server-side rendering, streaming rendering, enhanced navigation and form handling, islands of client interactivity, and then being able to decide which render mode you use at runtime. We have a whole bunch of framework improvements that are coming as well. The ability to statically generate HTML content using Blazor components, quick grid, sections, routing to named elements, monitoring circuit activity. One thing we didn't see today is that we are working to improve the authentication support in Blazor. That's also coming. We should expect to see that progress on that in upcoming preview releases. And then on the WebAssembly side,
sorry, can you talk just a little? We had several questions about that authentication support in Blazor. Can you talk a little bit more about just generally what that means?
Yeah. So there was a really nice blog post that Jeremy Lickness put together that talks about what we're doing with auth all up in .NET 8. In general, we hear a lot of feedback about how setting up auth and dealing with auth, particularly in like SPA style apps, like if you're working with Angular, working with React, with an ASP.NET Core backend, that's kind of difficult. Blazor WebAssembly has similar issues because it's also basically a SPA app. The way we set up auth for those projects today is we do a full OpenID connected dance and we use a third-party component for the OpenID Connect provider. We use Duende's identity server component. Duende identity server has since moved to a commercial license, so the fact that we still include it in the templates has been, a bit controversial. It does have a free offering if you're doing it for open source, if your company's below a certain revenue amount, but it is fundamentally a commercial license. So we are moving away from using Duende identity server in our templates. Instead, we are, for most SPA scenarios, we'll actually move to using same-site cookies. And we are providing endpoints for ASP.NET Core Identity that you can then use to call to get data about users, and even issue tokens if you need to do token-based authentication, like from a mobile application. So we'll be shifting to a more cookie-based model for our default templates, and then also providing endpoints for ASP.NET Core Identity for handling getting user information and also token issuance in .NET 8. For more details, I really encourage you to go look at the authentication blog post. It kind of lays out all aspects of this effort.
Cool. All right.
Yeah. Cool. And then the last bit was just the WebAssembly investments. So multi-threading, JITterpreter, hot reload improvements, SIMD and exception handling, CSP compatibility, and the web CIL packaging. WASI is that should probably have a preview thing after it. That's an effort that we're starting in .NET 8, but we'll probably release in a stable form post .NET 8. For all of the work that's happening in ASP.NET Core, you can check out our roadmap at aka.ms/ASP.NET/roadmap. And that is what I had for you today. What else do we have? Any more questions? We have a few more. Maybe we're a little over.
Yeah, we have a
Do you
few
have any more
thousand questions. All right, let me try and go through some of them. Okay, so I'll take some of the easiest ones first. Okay, so when do we get it? Yep.
November. Every November.
Yep.
There will be a .NET release for now and until forever, until .NET 2763. There will be a November release of .NET.
Yep. Cool. Okay, so you covered it at the beginning, but there's still some questions here, like what happened to Blazor United, where did Blazor United go, etc. So
Blazor United didn't go anywhere. We just decided not to use that name anymore. So the problem with Blazor United as a name is people kept asking, we're saying like, oh, do I have to like port my app from Blazor to something else? Is this a new hosting model? People thought this meant that this is a new framework or a new thing. Blazor United really is just a bunch of new features in Blazor. Blazor United is just Blazor in .NET 8 to a large extent. It's kind of a theme, like it's a bunch of features that are around enabling full stack web UI support, but it's not a new framework, it's not a new hosting model, so we decided to stop using that name to avoid people thinking that this is something completely new. It's just Blazor in .NET 8, a Blazor web app.
Okay, cool. Let me see. Question, you showed some WASI stuff. Is there like an overlap with Docker WASI?
Yeah, so like Docker has been doing a bunch of cool work to provide dev tooling to make it easy to manage WebAssembly based nodes. So if you're using the Docker tooling and you were spinning up some WebAssembly code and you wanted that code to be .NET code, you could use the .NET WASI SDK in order to do that.
Cool. All right, ripping through these. JITterpreter, AOT, and WebCIL address file size and loading speeds.
So JITterpreter addresses specifically runtime execution performance. Like up till now, the .NET WebAssembly runtime has been a .NET IL interpreter. So it doesn't. I mean, it's very functional. It's small. Well, in terms of like as far as .NET runtimes go. But it wasn't particularly fast at executing CPU-intensive workloads. And that's because there was no JIT. With JITterpreter, there's now a JIT tier to the .NET IL interpreter that will take chunks of your .NET IL and turn them into WebAssembly code blobs and then load them synchronously so that they execute much, much faster. So that's runtime performance. AOT is also about runtime performance. And it will go even faster than JITterpreter-based performance because it's taking basically all of your code and turning it into WebAssembly, but at the expense of a much larger download size. When you take .NET IL and turn it into WebAssembly, you end up with a lot more instructions than the original .NET IL had, and so the size of the code base gets larger. So no size improvement there. WebCIL is about making Blazor WebAssembly apps more friendly to restricted environments that don't like the transfer of DLL files on their network, or like antivirus software that thinks that anything that looks like a DLL must be suspicious. It's a more web-friendly packaging format that we're introducing for .NET 8. It may like slightly decrease the download size because we're stripping off some PE file headers. Like we're basically taking the .NET DLLs and removing stuff that is associated with Windows native executables. But we're talking probably very negligible size improvements there. There's not in .NET 8 in terms of decreasing the download size of Blazor WebAssembly apps per se. It's pretty much the same story as what we had before. We have the IL trimming. We have the WebAssembly linker capability to like relink the runtime to shrink it. We do compression. We try to make the app as small as we can. And the smallest Blazor WebAssembly app is still about a megabyte in .NET 8. Where things I think are game-changing is the idea of leveraging server-side rendering in your Blazor applications. There is zero JavaScript bundle size or WebAssembly download size for a server-side render application. All the hard work got done by the server. The page loads like that. It's like instantaneous. The best possible load experience you could imagine. Way better than doing something with React or Angular or Vue or whatever, because you're not having to download a bunch of client-side code to render the page. You can take content in your app and just server-side render it to make it load very, very quickly. You only need the client-side pieces when you're doing like rich client-side interactivity, the parts of your UI that need like drag and drop or things like that.
Mm-hmm. So then the advanced, like the improvements in the hosting model that I'm forcing my brain not to say United, but the improvements in the hosting model and component model that you showed at the beginning allow, like you could use those together. You can use server-side rendering, and then the interaction is just as you need it, or you know, it's streamed or that sort of stuff.
I mean, my goal today was mostly to show what has currently been implemented in .NET 8, but we've shown in previous demos that when you add like an island of interactivity, like you have a page that you want to have a Blazor server circuit associated with it, the circuit only gets created when you browse to that page. And then when you browse away, that circuit goes away. So your resource allocation is just limited to people on that page when it's needed, as opposed to for it being the whole app. Same thing with WebAssembly. If you decide to have a component that's going to use Blazor WebAssembly, we download the runtime only when you go to the part of the app that actually requires it. And then once it's cached, of course, any future use can be reused. We are also planning to support the auto mode, where you could start out a user with Blazor Server, which has a very, very small download size in order to just set up the WebSocket connection. All the work's really happening server side with Blazor Server, but then we sneak down the WebAssembly runtime in the background. And then once it's cached, the next time the user comes to that page, they can use WebAssembly, and you can offload. Instead of doing all the work from the server, you can now handle it from the client, and the user never saw the download, the load time hit for having to pull down the WebAssembly runtime, because it was kind of done in the background, in a clever way. So that's coming too.
Okay. All right. Let me see. I'm trying to grab the questions are coming in faster than we can answer them. So let me see. Okay. Here's one, I guess. Client side. Do all the client side components end up in the same WASM binary, or can they be partitioned out in large apps?
So they can be partitioned into multiple binaries. Like you can create, we often call them Razor class libraries. These are just libraries of components. They're DLLs, .NET assemblies that happen to contain Blazor components. That's why we have this cool ecosystem of components that you can just grab off of the NuGet. QuickGrid is like this. QuickGrid is just a NuGet package that has a library in it with the QuickGrid component. So you can have multiple assemblies. The question really becomes, when do those assemblies get downloaded? If you're dealing with particularly the WebAssembly based model, where you're going to move stuff over to the browser. By default, everything just gets downloaded at once. Like we download the entire app and its dependency graph so that you just have it all. In general, with most Blazor WebAssembly apps, the main bulk of the size is the runtime. So the DLLs are typically fairly small, so they're not as much of an issue. Now, that's not always the case. There are .NET assemblies that are large, like Newtonsoft JSON is a common offender. So if you just randomly pull in a dependency into your Blazor WebAssembly app, and that dependency is like 3 megabytes, well, you're going to be downloading a 3 megabyte DLL to load your application. There's a couple ways you can mitigate this. You can use lazy loading, which is a way in Blazor WebAssembly to say, don't load this assembly until I tell you. You can do that. So like, I only need Newtonsoft.json on this page, so I'm only going to load it on that one page. You don't need it, by the way. Like you should just use system text JSON. It's faster and it's built for linking and all these nice things. So that would be your JSON stack of choice. But maybe you have some other large dependency. You can limit it to only be loaded on a particular page with lazy loading. You can, if you have a large dependency that you have some influence over, you can make sure that dependency supports trimming. So .NET and Blazor, we have the ability to go looking at the code and statically analyze what code is actually being used in the app and trim out all the code that's not being used. It's very similar to tree shaking in the JavaScript world. But we, by default, will only do it if on an assembly, if the assembly says that it supports it. The assembly has to have like an annotation on it that says, I have done the needful work to make sure that I work correctly with trimming. Because if you're just going to randomly remove code from an assembly, it might be doing weird reflection, or who knows, some sort of code gen pattern that might need that code still, and the trimmer doesn't know unless the library has been appropriately annotated. We've done all that annotation work for our frameworks, like aspnet core, the core framework libraries. Those are all set up for trimming. If you have a dependency that you want to use, check to see if it's got trimming enabled on it. So if the library author has done that work. If they haven't, ask them if they'd be willing to do that work, or maybe it's a library you own, you could do that work. There's wonderful docs on how to author a library that supports trimming. If it doesn't support trimming and you can't get it to support trimming, then you might want to consider a different dependency. Like you do have to be mindful in Blazor WebAssembly apps what dependencies you're pulling into the application. Don't just pull in stuff willy-nilly, because then you'll end up with a 20 megabyte size app, and that's no good. You want to be intelligent about what your WebAssembly dependency graph looks like.
Or and then maybe move some of those to like a server-side API that you call separately, or that kind of stuff.
Any dependencies that are big that you still need, just leave them on the server. You could use the Blazor server model as one way to handle that, or put it behind an API that you call from your Blazor WebAssembly app. All those things are possible. Cool.
All right, I narrowed it down from 20 questions. I've got 4 left for you.
Let's do it.
Okay, so going back to the things you showed way back at the beginning, could some of those be used in a Maui application?
So Maui apps are Blazor hybrid apps, which is that one is a different hosting model. Like in the Maui application, we're hosting the Blazor components directly in the Maui application. They're running on the same .NET runtime that the rest of the Maui application is using for its logic. And then they render to the web view through a local interop channel. So they're not actually running in the web view itself. Like there's no WebAssembly being used. There's no WebSocket being really like handled over the internet. It's kind of like Blazor server, but instead of a big long WebSocket, you just have a little tiny local interop channel with the web view. That's the way you should think about it. So everything that you've seen with like the full stack web UI features, these are all features really for web applications. They don't really apply to the Blazor hybrid scenario. So I'm trying to think if there's anything here that would be relevant. I mean, there is some interesting ideas that we have been thinking about, like where it's kind of a variant on the hybrid model where, just as today with not today, not yet, but in .NET 8, the plan is that like you can have a Blazor app that's largely server based, like it's doing server-side rendering, and then it extends itself to the client in just the places where it's needed. Like maybe it does some Blazor WebAssembly stuff in just this one part, and that happens client-side in the browser. It's kind of interesting to think about, well, what if we had a Blazor app that's very similar? It's server-centric, but it has the ability to extend itself into a native client application as opposed to the browser as a sort of like almost like a custom web browser built for it, where the app happens to already be packaged there and it knows how to run .NET code. Like that's an idea that we've been chatting a little bit about. Nothing planned for .NET 8, totally future looking. But if anyone wants to try and experiment with those concepts, like it might be a cool open source project to look at.
Okay. So you showed the HTML renderer. Could we use CSS isolation with that?
That's a great question. So CSS isolation is largely a build time feature. So if you have components that have .razor.css files, you're using the Razor SDK in order to build those components. So those CSS files, I believe, should get processed. But then you need, let me think here. Well, okay. So I mean, the HTML renderer is all about taking a component and rendering its HTML. So there's not really like this. The whole CSS layer usually gets applied by the browser later, right? Like you then take that HTML, you stick it in a browser, and you download the CSS that you want to apply to that HTML. So it's more. I mean, you can build the CSS bundles and then deploy them to your webs if you're hosting this as a web app or like as a static site, and then use them that way. So in that sense, yes. But HTML renderer itself, no. Like HTML renderer is just about taking the component and rendering its content, which usually doesn't include any of the CSS stuff, right? Your markup and your presentation, your styling are separate.
Okay. All right.
Two more. Nodding. So I got that. I think I got that one right. All right. I got that right, Mackinnon?
That sounds right to me.
There are a lot of questions on circuits. There's one in here about detecting an idle circuit, saving state to local storage, serializing somehow.
Oh, yes. So like this gets into the whole pause and resume feature set. Like we know that people really want a way to better handle scale out with Blazor server apps, where you can like take the state of a circuit and drain it, and then save it, and then be able to rehydrate it elsewhere or rehydrate it later. These are all things that we are working towards, and some of the ability to monitor activity on the circuit is in that direction. The pause and resume feature to allow you to do all this state management for Blazor circuits has been something on our roadmap, I think, for two or three releases, and we've had to keep pushing it out because of other things. In .NET, was it the 7? We had to push it out because of the Maui effort. Took longer than we expected, and we had really wanted to do it in .NET 8, but all the work that we're doing to enable server-side patterns with Blazor ended up taking priority. So we still have that on our roadmap to enable at the framework level. The pieces that we're delivering right now are not they don't have everything that you would need to do that. There's probably more APIs that we need to add to make the experience good. But if anyone finds an innovative way to handle some of those problems with what we currently have, that would be great to share with the community.
Cool. All right. Hopefully an easy last question for you here. Is JITterpreter automatic, or do you have to do something to take advantage of it?
So it is built to be automatic. One constraint is that it won't execute if the app is built in debug mode. It only will be used if you're doing a non-debug based build. I think in like preview 3, there's an issue where for Blazor WebAssembly apps, we always run the runtime in debug mode, and so the JITterpreter during development always shuts itself off, which was sad, but I mean, that's just during development. When you then publish the application and you do a release build, then JITterpreter should always kick in and is just on by default. You don't have to do anything to enable it. And the intent is that you also can see the benefits of the JITterpreter during development as well when you're not running in the debug mode. And we're doing work in Blazor WebAssembly to make it so that if you're not using the debugger, then you can still see the JITterpreter benefits.
All right, that was incredible. I will cut off the questions there. They keep coming in. One was asking about what happened to the Blazor drawings on your wall.
Oh, ask me that. I actually still have them. They're sitting on the floor next to me. I was doing some like pre-record stuff, and I just couldn't quite convince myself that I was worried those pictures were going to be distracting for the pre-record content that I was doing. So I took them down for that. They will go back up. It was much to my wife and children's chagrin. They keep asking, Dad, do you really need to put those back up? Like, we drew those like years ago, and you don't need to show them anymore. And I'm like, no, I love them. They're going back up.
Awesome. Okay, my last question for people wanting to keep up with and go deeper on any of the stuff you showed. Best reference, the .NET blog.
Yep.
Okay.
Check out the .NET blog. You can download .NET 8 by going to get.net /8 to get the latest bits. And we will be publishing details about the upcoming preview releases on the .NET blog pretty much every month. So look for new bits every month.
Very cool. All right. Well, this was super long. We've got more and more people joining in the longer we go, which is crazy. So I think we should just turn it into an all-day event.
Well, it usually goes the other way, right?
Awesome. All right. Well, thanks. This was amazing. The last question here coming in. Are there recordings of the community stand-ups? Yes, there's hundreds of them going back like 7 or 8 years. So yes, they're all up on our .NET YouTube. So I guess with that, we should play the outro music. And Dan, you can install your Windows update.
Right.
So yeah, I've been choosing the best GIF to play here, and I think this is probably the best.
If we didn't get to your question, you can ping me on Twitter, or you can ask questions on GitHub as well. Like, feel free to reach out, and we're happy to chat with you.
Awesome. All right. Well, I'll play the outro music. Thanks, everybody.
Bye, everyone.
Bye.